This video goes over exponential functions and how to graph them based on key points and transformations. So the key points that you need to be familiar with are these three here. They correspond to the base graph y equals 2 to the x. We find those key points by substituting in x values to the parent function and then calculating the y values. The A, K, C, and D values are the same as in other transformations. A is a vertical stretch or compression. Minus A is a reflection in the X. K is a horizontal stretch or compression. Minus K is a reflection in the Y. C is a horizontal translation, and D is a vertical translation. So we're going to graph the following functions here. My parent function is y equals 2x, and my three key points are -1 and a half, 0, 1, and then 1, 2. The only thing that is different here is that I am taking away 3. So that means that my new points, I'm going to take away 3 from each of the y coordinates of my key points. So I've got -1, I've got 1/2, take away 3, which would be -5 halves. Then I would have 0, -2, and then I would have 1, -1. So I'm now going to plot those key points on there. So I've got -1 and -2.5. Then I've got 0 and -2, and then I've got 1 and -1. The other feature that you need on your exponential function graph is an asymptote. The asymptote matches the vertical shift, which means that in this case, my horizontal asymptote is at y equals -3. Once I've connected those points, I'm going to sketch the shape of my exponential function, which goes like this every time. And then I'm going to complete the chart down below. So my first function for A is increasing here because I am going up. Okay, I will be climbing up. My y-intercept is going to be at 0, -2. My horizontal asymptote is at y equals -3, matches my vertical shift. My domain is all possible x values. And my range is going to go from my horizontal asymptote all the way up to positive infinity. So let's sketch the second graph over here. Now I've got two transformations to apply to my key points. So my original key points are -1, 1/2, 0, 1, and then 1 and 2. The transformations that I'm applying is I am taking away 2 from the x, and I am taking away 1 from the y. So my new points for my transform function are going to be -3, -1/2. Then I've got, 0, take away 2 for the x, so I've got -2, and 0 for the y. And then from 1, 2, I'm going to take away 2 from the x, and I'm going to take away 1 from the y. So those are my new three key points that I'm going to use to plot my graph. So I've got -3 and -1/2, got -2 and 0, and then I've got -1 and 1. I'm going to add on my horizontal asymptote, which matches my vertical shift, which is -1. So that means that my horizontal asymptote is at y equals -1. And then I'm going to sketch my graph here. I think my y-intercept is actually 3, so I'm going to make my graph go up a little bit more, like this. Okay, so then I'm going to state the same criteria. This one is also increasing. My y-intercept is 3. You can figure this out by substituting in 0 for x. And solving for y. My horizontal asymptote matches the vertical shift. My domain is the same as the first, minus infinity to positive infinity, and then I go from -1 up to positive infinity for the range. The next two look a little bit different because they're a little bit more complicated, but I still have the same parent function. My base value is 2, so I have the same 3 key points. My first one is -1.5. My second one is 0 and 1. And then my third one is 1 and 2. So in this case, the transformations that I'm applying, I am reflecting over the x-axis, because that is a vertical reflection. I am vertically compressing by 1/3. I am shifting, so horizontal shift left by 1, and I'm also vertically shifting up 4. So those are a lot of transformations here, and I'm gonna move them off of the graph. So I'll put them maybe down here. Okay, so those are the transformations that I'm going to apply to my function. So the reflection over the x-axis means that I'm multiplying my y value by -1. So this would be -y. Vertical compression by 1/3 is that I'm dividing my y value by 3. Horizontal shift left by 1 would be taking away 1 from the x. And a vertical shift up by 4 would be adding 4 to the y. So all in all, I am taking away 1 from the x. I'm multiplying by -1/3 to the y, and then I am adding 4 to get my new values. So when I do that, my new x values, so I'm only taking away 1, I would get -2, -1, and 0. When I apply my transformations to the y, I'm going to get about 3.8, 3.7, and then 3.3. So again, I'm taking this y value and I am multiplying by -1/3 and then adding 4 to that value. I use my calculator to give me an idea of the fraction so that I could plot it. So on my grid, I'm going to put on my asymptote. It matches my vertical shift, which is y equals 4. So I can put that in here. And then I'm going to plot my points. So I have 2 and 3.8, got -1 and 3.7, and then I've got 0 and 3.3, so all those points are together. So they're going to follow the same general shape of my exponential function, except this time they're going down to the right. So this time I have a decreasing function. My y-intercept is 0 and 3.3. My horizontal asymptote we filled in before is 4. I've got -infinity to infinity. My domain is always the same. This time my range is -infinity up to the asymptote, just because of the nature of the transformations. So let's tackle one more. Here, my base is still 2. So this time, I have a reflection over the x-axis. I have a vertical stretch by 4. I have a horizontal shift to the right by 3. So the x is always the opposite. So that means the transformations that I'm applying to my key points are -x. This is 4 times y. And I'm also adding 3 to my x value. So overall, I am doing -3x. Oh, that's not quite true. That's a combination of both transformations. I'm doing -x plus 3. and then 4 multiplied by my y component. So my 3 key points that I'm starting with are the same as before. I'm going to put them over here. -1 and a half, 0 and 1, 1 and 2. When I apply those transformations, my new points are going to be 4, 2, 3, 4, and 2, 8. So in order to get these points, I took my x value, I multiplied by -1, and then added 3. To get the y value, I multiplied by 4 to get my new y coordinate. This now gives me 3 points that I can plot. I've got 4, 2, got 3, 4, and then I've got 2, 8. And my asymptote, there's been no vertical shift. So my asymptote stays the same at y equals 0. And then my function is going to approach my asymptote, going down to the right, and then going up to the left. I just need to check what my y-intercept is. So for my y-intercept, I'm going to set x equal to 0, and I end up getting y equals 32 in that case, which I can't show on the graph, so it'll go up like this. This is also decreasing because you would be sliding down if you went from left to right. My y-intercept I can calculate by putting in x equals 0 into my function. My horizontal asymptote is 0, matches the vertical shift. My domain is from -infinity to infinity, and then the range goes from my asymptote